Problem 1, you're given this big fraction and you want to simplify it. So let me just write this out. So for the numerator, let's just first expand all of these individual thingies. And we see that for this first parentheses, it has an exponent of 2, and using our exponent rules, we want to multiply all of these exponents by 2. So that will give us a to the power of 4, b to the power of negative 6, c to the power of 2. And then for this next parentheses, we're multiplying all of the exponents by negative 3, so that'll give us a to the power of positive 3, b to the power of negative 9, and c to the power of negative 9. And we can do the same thing for the denominator, and that will give us a to the power of 2, negative 2, b to the power of 6, c to the power of 4, negative 4, and then the next one, the last one, a to the power of 16, b to the power of 4, c to the power of 12. Okay, so we can simplify this even more by combining like terms for both sides of the fraction. So for the numerator, we're gonna combine the a's. So since the two a's, they're multiplied together, so we want to add the exponents together. So for a, 4 plus 3 is 7. For b, negative 6 plus negative 9 is negative 15. For c, 2 plus negative 9 is negative 7. And then we can do the same thing for the denominator, and we'll have a to the power of 14, b to the power of 10, and c to the power of negative 16. Now we can use another exponent rule and simplify this to this form. And to do this, for each of the bases a, b, c, we're going to subtract the numerator exponent by the denominator exponent. So for a, 7 minus 14 gives us negative 7, and then negative 15 minus 10 is negative 25, and then negative 7 minus negative 16 is positive 9. So now we have this form, and we just add the exponents together. So negative 7 plus negative 25 plus 9 will give you negative 23. Problem 2. Okay. So Rich is driving at a certain speed for 5 hours, and then he realizes that he could have covered the same distance in 3 hours if he had driven 20 miles per hour faster. And we want to find his current speed. So let's just let x be Rich's current speed, and we can set up the equation where we don't know the distance, but the distance is the same. So So this is basically how we're going to set up our equation. Distance equals distance, and I'll explain that later. And let's just recall that distance is just equal to time times speed. So for the first, for this first statement, he's driving at a certain speed, which is x, for 5 hours. So that will give us a distance of 5 times x. And then for this second statement, he would have covered the same distance in 3 hours if he had driven x plus 20 miles per hour. So this is our equation, and now we have to just solve for it. This simplifies to, or this expands to 3x plus 60. And then if we move some stuff around, we'll find that x is equal to 30. So his current speed is 30 miles per hour. So question 3, we have this 8 by 10 photo, and we want to shrink it. So first of all, this photo is the size, the width, and the length. They have a ratio of 8 to 10, or that's the same thing as 4 to 5. So basically, the reduced photo that we want, the width would be something like 4 times k, and the length would be something like 5 times k. K is unknown, and that's what we want. That's what we want to find. Okay? So, basically, we know that the shrinked photo, the reduced photo, has a perimeter of exactly 27. So we can use this, set that equal to 4k plus 5k plus 4k plus 5k. And that will be the perimeter. This is just the perimeter of our reduced photo. And we can see that this simplifies to 18k. And now if we solve for k, we'll get k is equal to 27 over 18, which simplifies to 3 over 2. And now we know our unknown, okay? So this number, 3 over 2, that's just how much the photo, okay, so since we know that the size, the width of the reduced photo is 4k, we can find what the width. See, we just multiply 4 by k, which is 3 over 2, and that will give us something like, and that will give us 6, okay? And we do the same thing for the width. So 5 times 3 over 2, that is 15 over 2. And now, basically, we have the dimensions of the reduced photo. And we just want to find the area. 6 times 15 over 2. And that will give us 45. That's the area. All right. Problem 4. So Homer is peeling potatoes, okay. And then 4 minutes later, Christian joins him. Okay, so after 4 minutes, Homer peels 3 times 4 equals to 12 potatoes. So Homer peels 12 potatoes. And this number, this 12, comes from the rate, Homer's rate of 3 potatoes per minute and the 4 minutes. So after 4 minutes, there are 44 minus 12 potatoes left to peel, or 32 potatoes left to peel. So when he joins Homer, they have a combined rate of peeling 8 potatoes per minute. So if we divide 32 by 8, we'll find that it takes them 4 minutes to peel all 32 potatoes. But we want to find how many potatoes Kristen peels. So in 4 minutes, he can peel 4 times 5 potatoes, and that will give us 20 potatoes. So that's how many potatoes Kristen peels. Okay, question 5. So this question is actually pretty similar to the first question from last week. We're going to be using the same concept of complementary counting. And basically, complementary counting is, if you recall, it's just the total probability, or 1, subtracted by the probability of what you don't want. So in this case, you want to find the probability that the product of 2 numbers is a multiple of 5. So to get a product that's a multiple of 5, one of the numbers rolled has to be a 5. So if you don't roll a 5, then basically you won't satisfy this condition at all, and that's just the probability of what you don't want, which is rolling no 5s. So the probability of not rolling a 5, for each die, it's 5/6. So the total probability of the combined probability, this is equal to 25/36. And now we put it back into this formula. So 1 minus 25/36 gives us 11/36. And this is the probability that the product of 2 numbers is a multiple of 5.